So type of movements, depending upon the direction of rotation, the movements are of two types: clockwise movement and anti-clockwise movement. So in clockwise movements, whenever your force acts uh, like this, then the body will try to rotate in clockwise direction. So at that moment is called clockwise movement. And for example, if any force acts like this, then that body tries to rotate in anti-clockwise direction. So that moment is called anti-clockwise moment. So here clockwise moment. So this moment is clockwise moment, and this one is anti-clockwise moment. So according to the law of moments, if your body is in a equilibrium, if you say if it is in equilibrium, means the algebraic sum of all the moments acting on the body, all the algebraic sum of moments of all the external forces about any point, it will become 0. So algebraic sum of all the moments will become 0. So this concept is called law of moments. So here clockwise movements and anti-clockwise movement, if you add clockwise movements and anti-clockwise movement, if you add all the movements, then if you get 0, then you can say that body is in equilibrium condition. So here sigma m, so algebraic sum of all the moments, if algebraic sum of all the moments becomes 0, then the body is said to be in equilibrium. This is the third condition. So in equilibrium conditions, if algebraic sum of all the horizontal components becomes 0, should be 0, that is sigma fh equals 0, and algebraic sum of all the vertical components should become 0, that sigma f equal to 0, and the algebraic sum of third condition is algebraic sum of all the moments should become 0, sigma m should be 0. So this is the moment. Another one more principle of moments are there, the Varignon's principle of moments. So Varignon's principle states that algebraic sum of moments of a given system of forces about any point in the plane of the force is equal to the moment of their resultant about the same point. So that means algebraic sum of moments of a given system of forces. For example, if two forces are acting like this, some F1 and another force some F2 with distances some R1 and R2, then algebraic sum of the moments will be equal to some F1 R1 plus F2 R2. It should be equal to the moment of the resultant. For example, if you consider this as the resultant, for example, if you consider this is the resultant R, then F1 R1 plus F2 R2 will be equal to some R into perpendicular distance, some R, smaller. So F1 acting at a distance of R1 and F2 is acting at a distance of R2 from this point 4, and so the algebraic sum of the moments of those forces will be equal to F1 R1 plus F2 R2, and here the resultant, the moment of the resultant will be equal to some capital R into smaller. Smaller is distance from that point O to line of action of the resultant force. So according to Varignon's principle of moments, the algebraic sum of the moments of the forces should be equal to moment of the resultant. So this is also known as principle of moment. This is nothing but law of moments. So in law of movements also, law of movements means here algebraic sum of all the moments should be equal to 0. That means algebraic sum of the moments of the forces will be equal to the moment of the resultant. So both are same. Law of movements or principle of movements or Wegener's principle of movements all are same. So next one is couple. So in this figure, if you observe two forces, so those two forces are equal in magnitude. So that's why two equal, unlike parallel forces. These two forces are equal and parallel, but they are in opposite direction. That means whose line of action are not the same. So if a couple is forming means two equal unlike parallel forces whose line of action are not the same, then they will try to form a couple. So here two equal forces F, they are separated by a distance called R, and due to this two equal unlike parallel forces, a couple will be formed. Due to this couple, a body may rotate. So the effect of the couple is to cause the rotation of the body. So a couple can be described as the movement produced by two equal and opposite forces acting together. So a couple is nothing but you can describe as movement only. So movement produced by two equal and opposite forces is called a couple. So moment of that couple will be equal to any of the two forces F into distance which is separating them. So that is F into R. So moment of the couple will be equal to F into R. So that R can also be called as arm of the couple. So the distance which is separating the two forces, here we are calling that distance as arm. So arm of the couple here is R. So coming to the classification of the couple here, depending upon the direction in which the couple tends to rotate, the body couple is classified into two types: clockwise couple. So because of these two unequal unlike forces, a couple is forming, and here in the first figure, due to these two forces, we are going to get a clockwise movement. So that's why this couple is called clockwise couple. And in the second figure, due to these two forces, you are going to get anti-clockwise rotation. So that's why this couple is called anti-clockwise couple. So next one is triangle law of forces. So according to the triangle law of forces, it states that if two coplanar forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of a triangle taken in order, then the resultant may be represented in magnitude and direction by the third side taken in opposite order. So here two forces P and Q. So here P and Q acting on a body, they are going to be represented by the sides of a triangle. So if P and Q are represented as the two sides of a triangle, then the resultant will be represented by the closing side of the triangle. So here the red color side is closing side. That closing side of the triangle, here we are taking in opposite direction. So that red color closing side of the triangle can be here called as resultant. So here we are representing the resultant by the third side taken in opposite order. So whatever the concept we have learnt in parallelogram law of forces. So there in parallelogram law of forces, if two forces are represented as two sides of the parallelogram, then the resultant can be represented as the diagonal of the parallelogram. So in parallelogram law of forces, we have learned that in triangle law of forces, the third side of the or closing side of the triangle can be considered as the resultant. So using this triangle law of forces, this triangle law of forces is useful in determining the condition of the equilibrium. So according to this triangle law of forces, you can give statement in another way also. If three forces acting at a point be represented in magnitude and direction by the three sides of a triangle taken in order, so they will be in equilibrium. So you can give this type of statement also, because triangle law of forces or polygon law of forces, all these laws, they are going to find out the condition of the condition of the equilibrium. So whenever the three forces acting at a point represented in magnitude and direction by the three sides of a triangle taken in order, then they will be in equilibrium. So coming to the polygon law of forces, this law states that if any number of coplanar forces acting on a particle or a body be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all the forces may be represented in magnitude and direction by the closing side of the polygon. So instead of the triangle, here we are considering polygon. So whatever the number of forces are acting on a particle or body can be represented as the sides of the polygon taken in order, then the closing side of the polygon which is taken in opposite direction, that is, so can be called as the resultant. So here the resultant can be represented as the closing side of the polygon in opposite order. So the red color side of the polygon, the closing side of the polygon is the resultant. So this polygon law of forces is also useful in determining the equilibrium condition. So if number of coplanar concurrent forces acting at a point be represented in magnitude and direction by the sides of a closed polygon taken in order, then the forces shall be in equilibrium. So you can state this polygon law of forces in another way also, using equilibrium term. So whenever number of coplanar concurrent forces acting, then all the forces will be in equilibrium whenever you consider all the forces as the sides of the polygon. So next law or theorem is Lami's theorem. So it states that if three forces acting at a point are in equilibrium, each force will be proportional to the sine of angle between the other two forces. So whenever you consider three forces, if all those three forces are in equilibrium, then each force will be proportional to the sine of angle between the other two forces. So from this figure, here three forces P, Q, R, these three forces are in equilibrium. Then here we are assuming that the angle between the P and Q is gamma. Here we are assuming the angle between Q and R is alpha, and R and P is beta, and P and Q is gamma. So these are the alpha, beta, gamma are the respective angles between the various forces. So according to the Lami's theorem, so each force is proportional to the sine of angle between the other two forces. That means if you consider force P, So it will be proportional to the sine of angle between other two forces. Other two forces is Q and R. So finally, the angle between the other two forces, the angle between Q and R is alpha. So according to the statement, it is proportional to the sine of angle. Sine of angle. So in mathematically we can write P by sine alpha, and if you consider Q, then that Q by sine of angle between other two forces. Other two forces are P and R. So sine of angle means sine beta. So Q by sine beta. So next one, R by sine gamma. So P by sine alpha equal Q by sine beta equal to R by sine gamma. So if you considering P means P by sine alpha, means you have to consider sine of angle between other two forces. If you consider Q, then sine of angle between P and R, that is beta, sine beta. If you consider a force R, means R by sine of angle between other two forces P and Q, that is alpha, that is gamma. So R by sine gamma. So P by sine alpha equal to Q by sine beta equal to R by sine gamma. So this is the mathematical representation for the Lami's theorem. So using this Lami's theorem, we are going to solve some problems in the next class.